Hello, maurieo. In this video we're going to look at solving a right angle triangle. Solving it the surveyor's way, which might be slightly different to what the old mathematician might expect, but anyway, here's a go. In this case we've got the problem stated as in words. The hypotenuse of a right angle triangle is 27.16 meters long, and one of the other sides is 14.27 meters long. Calculate the length of the third side, that should be third side, plus the two missing angles. It's a slightly different pronunciation there of third. Never mind, we can carry on with that, I'm sure. We're big boys, we can see past that. Step 1, draw the problem. Well, it's a right angle triangle, so first thing to do is draw a right angle triangle. Let's have a look at what information we've got. The hypotenuse, now that's the largest side in the triangle opposite the right angle, 27.16 meters long apparently, and then the other side, or one of the other sides, is 14.27 meters long. So there we are, we have a bit of a diagram drawn. Label the triangle in the conventional way. Usually I make the right angle C and then the other two sides A and B, or the angles as it turns out, and then the side opposite angle A we call little a, and the side opposite angle B we call little b, and the large side opposite the right angle, the hypotenuse, is called little c. So next thing is to use a plan. Now in this case here I would plan, or my plan is to use first of all good old Pythagoras. The square on the hypotenuse is equal to the sum of the squares on the other two sides, or as it is expressed quite often, c squared equals a squared plus b squared. We can also see there that we could work out the sine of a at this juncture, and the sine of a of course is the opposite over the hypotenuse, 14.27 over 27.16. So looks pretty easy from here, and we'll move on through. So let's go to step 3 and let's just solve it. C squared equals a squared plus b squared. Substituting in our numbers that we have, C is 27.16. Let's see, A is 14.27, we're going to square that, and that leaves us with B squared. So a little bit of rearranging here, taking 14.27 squared off both sides, and that'll leave B on one side, and then let's have the B on the left. We get B squared equals 27.16 squared minus 14.27 squared. But we don't want to know b squared, we want to know what b is. So if we take the square root of both sides, as I've indicated there in the magenta shading lines, square root of both sides, we get b equals 23.10915. You'll notice how I've left all of the calculation right to the end as far as I can. This way I retain a fair bit of accuracy. I don't lose too much by rounding and what have you. So now that we've got our length of side C, 23.10915, that's a bit bloody ridiculous really, considering that we only started with 2 decimal places. So let's just round it up to the nearest 2 decimal places, 23.11. Fill that in the diagram, that's our answer. Let's take that. Now moving on to plan B, or part B of the plan A, whichever way you want to look at it, we get sine A equals 14.27 as we said. Now we know that A equals the inverse sine to the negative 1, 14.27 over 27.16. Notice how I've left all of the calculation right to the end so that we can get the maximum accuracy into our answer. So here we go. A equals 31 degrees, 41 minutes, 44. Now you may need to work out how to do that on your calculator, and I have done some videos using the HP 15C, and there are the various other ways. So that's something that you may need to find out, bone up on, or work out for yourself. Now we all know that the 3 angles of a triangle add to 180. where C is a right angle, or 90, that's half of 180, so that means the angle at A and the angle at B must add up to 90. Right angle triangle, yeah, the other sides, the other angles add up to 90. So if A is 31 degrees 41 minutes 44, then B must be 90 minus 31 degrees 41 44 seconds. And it looks like I've left off the seconds there, but fortunately we're ready poised here with the pen and we can fix that up right now, if not in a very skinny style. So there we go, we've got that in there. It sort of looks more like an 11 than a seconds symbol, but there you go. Now we take that away and we get 58 degrees 18 minutes 16 seconds for the angle at B, which I've once again have forgotten to put on the diagram. So I'll just bump up the size of my little brush size here if I can. Just might take it a little bit. There we go, 10. And we're just going to write that in there by that little dot there. So let's see if we can draw that in, and here we go, and that's 58 degrees 18 minutes and 16 seconds. Now we're surveyors, so we like to do independent checks, check our stuff independently. Now, the more discerning of us, there's a number of ways of checking this. I thought it would be nice to actually start, or I thought it would be nice to start with the actual original information to check what B was. And looking at angle B there in a right angle triangle, we can see that angle B, we could work out the cos of B using the original data. Cos B, of course, equals 14.27 over 27.16, which is actually the same ratio as the sine one there. So I wonder just perhaps how independent this check is, but nonetheless I've done it, and I've got B equals cos to the negative 1 of 14.27 over 27.16. And going to my calculator, I find, and I did this honestly, I just didn't copy it from down the bottom there, 58 degrees 18 minutes and 16 seconds. So that's very good, it all checks out. I'm satisfied that I have solved that right angle triangle. I know all the sides and all the angles, and I'm pretty sure that I've got it fairly right. So that's good. So all good, thanks very much. And that's a one right angle triangle solved.